I'm Marc. I'm going to talk about VisionCamera. Who here knows what VisionCamera is? Okay, yeah, then I don't need to do the talk, I guess. Okay, no, here's the QR code. I would recommend you guys scan it now, because if there's any questions, just throw them in there. And if I say any, terminology that's not familiar with you guys, then just, raise your hand and I can explain there. Yeah, has anyone not scanned the QR code yet? Can show it for a quick more second. No, I think it. Oh, okay. Yeah, that's me. So my name is Marc. I'm CEO of Margelo. Yeah, I'm also a maintainer of a couple of open source libraries. I maintain React Native VisionCamera, MMKV, Blur Hash. I forgot the names. React Native Big Number, Quick Crypto, Graph, and some other small libraries. Yeah, I love API designing. So, yeah, this is us, Margelo. You've probably met the other guys here. Christoph is here, Tars is here, and Hanno is here. And we work together with ExpensiConX to make their app better, but Hanno already said that yesterday. Yeah, so the key takeaways here of this talk are I'm going to talk a little bit about how to design good APIs, so that in case you want to design a native module or an API in general, maybe there's some important lessons here to be learned from my experience. I'm going to talk a little bit about how cameras work. So, the underlying hardware sensor, the camera APIs that the native platforms provide. And we're going to take a look at a very specific high performance critical problem and how to find a good solution for that. But more on that later. Yeah, this is the structure of my talk. I'm going to talk a little bit about the history of VisionCamera, so why I created VisionCamera. Then I'm going to go into how cameras work under the hood, how to build a native module, so how to wrap the native platform APIs and expose them to React Native, and about frame processors. So that's going to be very technical, I guess. Yeah. So the history of VisionCamera back in 2019. That's already 4 years ago. Wow. I worked in a social media app startup with Hanno, and the main focus of the app was the camera. So it had 3 very important requirements, I think. Those were, it needed to be as fast as native. You needed to have full control over the camera, so all the camera features. And later, more down the road, we wanted to have filters. And all of this sounds like Snapchat. So yes, our main competitor was Snapchat, so we didn't stand a chance. Spoiler alert: the startup failed. But yeah. Pretty strong requirements for a React Native app, right? Next slide. Yeah, so we had 2 solutions. We took a look at React Native Camera and React Native Camera Kit. At that time, those were the 2 main camera libraries. I think ExpensiConX was also around, but it wasn't as easy to integrate that at that time. Let's take a look at React Native Camera first. It was already unmaintained at that time, so it was kind of like a no-brainer. Let's not use an unmaintained library. Plus, it had lots of platform specifics. Going to talk about that in a second. It performed a little bit slow in our tests. I don't have a benchmark or anything here right now, but it just performed slow in our tests. And it had a few missing features that just didn't fit our requirements, I guess. So platform specifics were properties that were available on one platform, but not on the other. On the right, you can't read anything at all, but it says, I think this one here says Android permission dialog title or something like that, which is something that works on both platforms, but they only implemented it on, on one. And then they kind of added it later using a different name for iOS. And it felt like you're building, 2 apps all over again. So that's not like the philosophy of React Native with like write once, run anywhere, I think. Yeah. And it had features like barcode detection. So like there was a QR code scanner function or like a callback, which used MLKit under the hood. So, or MLKit barcode detection thing is the whole class name. And that worked fine. But, if you want to use some custom QR codes or anything like that, you're kind of, forced to use that one library, and you have to probably fork it or hot patch it to use something different under the hood. Right, so the missing features, you couldn't select any camera device. Can anyone, I guess, understand what a camera device is on a phone? Yeah, looks like everyone gets that, okay. You couldn't select custom FPS ranges or HDR modes. You couldn't switch from front to back camera while recording, very specific things. You couldn't continue recording while getting a call. All those kinds of very specific things just weren't, supported at that time. And yeah, so let's take a look at React Native Camera Kit instead. Overall, the API seemed better. So it had a better API design. It was maintained by Tesla at that time. I think Wix did it before, and then Tesla took over. And they had only non-platform specific, kind of weird wording there. They had no platform specifics. So, everything that you wrote worked on both platforms. But it was more or less built for simple use cases. It also had a cool simulator preview, so you have balloons over here. And yeah, missing features, you couldn't record video. So that was it already for us. So what do? We built our own camera. So this seemed fairly simple, but apparently it was not simple. So yeah, API design is pretty hard. I wanted to have, the API. I wanted the API to be good. I wanted to, the goal was to release it to the public. So I followed like 6, I guess, philosophies here to make the API good. First one, it should be user-friendly. API, you're the user of the API, so you want it to be user-friendly. It should be intuitive or self-documenting. Obviously, there should be documentation for advanced use cases, but if I use an API, if I use a camera, I just want to write the code and not look onto the documentation for the basic stuff. I just write it and expect it to work. I wanted it to have lean core, so that's the same philosophy that React Native Core is following, with not a lot of hard-coded dependencies and everything in there. So I wanted the core or the fundamentals to be very lean. And the rest will be, plugins or third-party modules that can integrate into VisionCamera. More on that later. No platform specifics, also pretty obvious. I think everything should work on both platforms. That's the whole idea. No compromise, and all of that, I want to achieve all of that with without any compromises in flexibility or performance. So yeah, native modules lack documentation. If you ever written a native module before, you know that there's a little bit documentation on the React Native website, but even Meta agrees that there's not enough yet, I guess. So you have to browse the React Native core code base a lot. You have to browse other React Native modules a lot. For example, I took React Native WebView as an example. Where's T-Bolt? Somewhere here. But I had a little bit of experience before because I created React Native blur hash. Yeah, and I came up with the name VisionCamera because our founder at that startup always had this big vision and wanted to bring it onto everyone. Plus, it was also quite convenient because computer vision and VisionCamera, everything just kind of felt right. I'm going forward a bit, forward in time to kind of give you like 3 tips or turn my mistakes into tips here. So mistake number 1, I created the native module in our main app. That was a bad idea, right? It seemed very obvious that you want to do it in the main app or in the app you're working on, because that's where the camera should go. But obviously it slowed builds down drastically. So there was ton of third-party modules, ton of build scripts and everything, and it was all really, really slow because I had to do lots of native changes. After all, I'm writing a native module. So yeah, if you do a native module and it's like a really big native module, you should probably start with an extra app, from the beginning. At least if you plan to release it on NPM. Yeah, mistake number 2, I tried to do too much planning. So I designed the API from JavaScript first. I was kind of like designing my JSX component. I was like, okay, this is how it should work. And then I started implementing it on iOS, and yeah, nothing was gonna work that way. So you gotta take a look at the native APIs first, see what's possible, see what you can expose, because most of the time those native APIs are imperative, and React Native is declarative, so you need to figure out what can you actually expose to a declarative API, and then kind of do one more iteration on it to just kind of see, okay, this is how I can expose it, how can I make it a bit smoother, how can I remove a few unnecessary details, how can I make it less verbose. Yeah, and the third one is where the fun begins. I assumed that everything that was possible on iOS was also possible on Android. That's a huge mistake. Yeah, so it doesn't work the same way on both platforms. Yeah, let's go a little bit into detail on the iOS implementation. So on iOS, you use AV Foundation. AV stands for audio video, which includes the camera. And there's only really this one framework for working with the camera. There is lots of documentation for basic stuff. who, like, if you worked with Apple APIs before, they're actually fairly good in my opinion, at least compared to Android. There's a little bit of documentation for advanced stuff. So I think there's documentation for writing your own muxer, for all kinds of like really, really advanced stuff. But it is closed source. So if you hit some limits, if there's no documentation for something, you're kind of fucked actually, because you can't really take a look at the implementation. I chose Swift as a language. I think that's a no-brainer. So if you've been living under a rock for the past 12 years, this is what an iPhone looks like, or at least a modern iPhone. So an iPhone has capture devices. A capture device is actually a device that captures video or audio, so a camera or a microphone. Can anyone tell me how many capture devices this specific phone has? That's an iPhone 11 Pro. 4? Was it 5? 4? Anyone? Any? 6. Who said 6? Yeah, that's right. So it has 3 cameras on the back. There's the wide angle, the ultra wide angle, the telephoto. Going to go into in more detail in a second. There's the microphone on the back for recording. On the front side, you have a microphone as well. Hold on, 1, 2, 3, 4. Microphone at the front side, you have 5. And then the selfie camera. I think the iPhone 11 Pro has the true depth camera already, so it might be 7 instead of 6 actually. Yeah, so those are capture devices. Those capture, audio or video data. Yeah, so here's the core concepts on iOS. The AV capture device is the name of the capture device. One phone has N devices. For the iPhone 11 Pro, that's 7, I think, if I was correct. And a capture device has a few props. So you have a position back and front. You have a device type, which is the wide angle camera. That's a default camera on phones, because phones are, you hold them fairly close to yourself, so that you want to have, wide FOV, I guess. There's the ultra wide angle as well on newer phones. That's a fisheye camera, I guess, or the 0.5 zoom factor camera. There's the telephoto camera, which is on the iPhone 11. It's like at a 2x zoom factor. It's also at a 3x zoom factor on newer phones. And microphones are also devices. And each device has N formats. So I guess a format is kind of like a description on how you can record with this one specific device. So for example, for the back camera, let's take a look at one example. I might have a high FPS format, which is useful for slow motion recording. So I might have a supported FPS range of up to 240 FPS with a photo resolution of 4K, but then a video resolution of only 720p or maybe 1080p if it supports such high, data processing. Then there's some formats with lower FPS ranges, but higher video resolutions, up to 5K. Yeah, that's how it works. Then we have an AV capture session, which kind of just connects the inputs to the outputs. So we have, the camera inputs, AV capture device, and microphones as inputs, also AV capture devices, to one or more outputs. This might be a video output for recording a video, for processing frames, for detecting faces in a frame, for example. Same for audio. You can also process audio frames. Sounds a bit weird, but that's possible. For example, you can upload them to WebRTC for a web chat. That's also audio frame processing. You can do photo capture, and you can render them on a preview layer. That's also kind of a video output. It works a bit differently though. So I tested the performance on iOS. Here are some quite interesting findings, I think. So there are a few things that affect the performance or the startup time, I guess, of a camera. For example, multicam devices. Your camera connects multiple devices, so the stock iOS camera connects all devices available, so that if you have an iPhone 11 Pro, you have 3 cameras on the back, it connects all 3, and you can zoom in between them, right? That's a multicam device. If you use, or the more multicam devices you use, the longer it takes to start up. So all 3, takes time to boot up. It's a hardware sensor, right? Video stabilization, that's interesting. Most phones have video stabilization, so you can, on the iPhone 11 Pro, you have video stabilization off, digital and optical. And optical is, hardware operation. So if you use that also takes way longer to start up. That's actually quite a big impact. So turning it off or to digital only is, faster. The number of inputs and outputs, I think that's obvious. If you have more inputs, more outputs, it takes longer to start. The audio session is interesting on iOS because you have to request ownership of the audio session. So that also takes some time. So yeah, it's recommended to do that in parallel. And keeping the session warm is also smart. So on Snapchat, for example, when you swipe to another screen, to the chats page, for example, it keeps the whole session warm. It just disables the streaming. So when you swipe back, everything is still active. The audio session is, still, I guess, in the app's ownership. And you just re-enable the streaming. Right. So this is where the fun begins again. Android. On Android, there's 3 camera frameworks. We have Camera 1, which is deprecated, Camera 2, which is complicated, and Camera X, which is not major enough-icated. Just wanted it to rhyme. There's getting started guides for basic stuff on how to use the camera. There's no documentation at all for really advanced stuff. So their idea of showing you how to use the cameras in more advanced stuff is just by creating a GitHub repo, adding no documentation, and just linking it. Like that's how it works. So I guess Camera 2 is the most popular of all of them. Actually, I'm going to go into that in a second. It is kind of open source. Android is open source. If you can read the Android codebase and understand it, then respect. Because there's multiple Google engineers working on it, and it's like really tricky. Plus, it's a lot of C++ code, so lots of NDK bindings. And the language I chose is Kotlin, because it's more similar to Swift. So which camera framework do we actually use for VisionCamera? Camera 1, deprecated, no-brainer, we don't use that. So it was deprecated in API 21. Old phones used it. It was very simple, so it was a cool API. I have a blog post about this where I go into more detail, but yeah. Camera 2 is really complicated. So on the right you can see, this is a fun list. On iOS you have, or I guess Camera 2 is callback based, so you get a callback or a message for each, state change, I guess, in Camera 2. And the auto exposure state on Android apparently has 29 different states. I don't know why, on iOS there's 3 or 4. But yeah, that's, and you can imagine how the rest of the API looks. You also have lots of device-specific code required because Android runs on many different phones. There's, some Huawei that just don't show a preview. Then there's some Samsung devices that rotate the hardware sensor not by 90 degrees but by 180, and then the image is flipped and weird stuff. There are a few examples on GitHub, and there are a few libraries that use Camera 2 under the hood to kind of wrap it into a more, human-readable API. So there's, I think, Camera View and Camera Kit Android or something like that. One of those actually uses C++, which is quite interesting. So you can use Camera 2 from C++ as well, because it's called Camera 2 NDK. If you want to use it, I don't know. I mean, yeah, it's a bit weird. Camera X is actually recommended by Google. It's the newer library, I guess, because people kept complaining about Camera 2, how hard it is to use. So Google just made, or I guess Jetpack Compose made, Jetpack made the Camera X API. It is actively maintained, and at the time of building VisionCamera, it just got out of beta. It's based on Camera 2, as I said. There is documentation for basic stuff, but no documentation for advanced stuff again. But there are a few examples on GitHub. And I think there's one Android distribution that actually uses Camera X for the camera. So that's quite interesting. So I decided to use Camera X. It was more simple to use, I guess, and it made more sense because I could support more Android phones than if I used Camera 2. Because, I don't have 1,000 phones at home to test everything. So I just used Camera X and just depended on, their, I guess, word. I just relied on their word. I guess they said it works everywhere. So, yeah. Right, so let's compare the core concepts between iOS and Android. On Android, or like with, this is Camera X specific, so not Camera 2. On Android with Camera X, you have a very declarative approach. So you, instead of, having this one device and format API and connecting them imperatively, you just create a session, bind it to your current view, to the lifecycle of the view, and then you set the target resolution and target aspect ratio, for example, for the inputs. And the funny thing here is it tries to find a matching format, but if it fails, it just chooses a different format that works, so you really have no idea what format is being chosen in advance, which is a weird API. So yeah, you attach use cases. That's similar to the iOS outputs. You have, preview use case, photo use case, record video use case, and image analyzer for processing frames. Fun begins here again. Most devices don't support all use cases at the same time. So this is where the snapshot trick actually comes in. Snapshot, so for example, on some phones you can only use 3 use cases. On some phones you can only use 2 use cases. But let's assume we can use 3 use cases. Snapshot uses the preview, record video, and image analyzer use case. And for taking photos, they actually take a screenshot of the view, which is kind of weird. Yeah. Limitations. Yeah, CameraX is not based on the same concepts as iOS. I said that before. There are multiple camera devices, but no format. So you can't really, there's a way of finding out what resolutions are supported and what FPS are supported, but you don't know if every FPS works with every resolution. Weird stuff. No multicam support in CameraX, no FPS setting supported in CameraX, and no slow motion support in CameraX. So this is when I talked to a friend of mine who worked at Google. This is the meme he sent me. He said, "Yeah, this is just how it works." It says, "Welcome to Google" at the top. On the left side, there's the main road, which works fine. It's just a bit, dusty, I guess. But they put like a label on it, deprecated. Don't even think about it. On the right side, there's the new road that you should use, but it doesn't lead anywhere. So that's how it is. Yeah, but we made it. I released VisionCamera 1.0. I don't remember when exactly that was. I think sometime in 2019. And it was cool. It worked. So we had more features than the other camera libraries. It was faster than the other cameras. It had a clean API, at least that's what I think. It was fully cross-platform. So everything that works on iOS also worked on Android. The things I said before about not being able to choose FPS, that's kind of like an asterisk here, because you have an API where you get all of the devices and all of the formats that you can use. And on Android, it just doesn't show any 60 FPS formats. So technically, everything works on both platforms. Here's a quick demo of the fast capture working. You can prioritize between quality and speed on iOS. So this is the capture speed. So the moment you see like a red circle here, it starts taking the picture. Quite fast for a 4K image. This is zooming, smoothly. I'm not sure if you can see it here. The resolution isn't great, but you're actually zooming between the fisheye camera and the normal camera, and it just smoothly, animates between them. That's an OS feature, so it's not something I built, but you still have to connect those, and it doesn't work in other camera libraries. That's built with reanimated and gesture handles, so you can pinch to zoom and just pass it along to the native module. Errors are actually fun. There's a ton of things that can go wrong. I mean, it's still a hardware sensor, right? And all of the errors are actually fully typed. That's inspired by Firebase. So every error has like a domain and then a short error, I guess, not message, like a ID. So for example, capture/recording in progress, very self-explanatory, I think. So you can catch all of those and have full types support. It gained lots of traction. So there were some blog posts about VisionCamera that I didn't even write. Some Twitter posts, Reddit posts on Stack Overflow. It was quite lots of questions there, and there's even YouTube videos on VisionCamera. So quick recap: the initial requirements. Did we meet them? As fast as native? Check, or at least close to native speed. I guess there's still the overhead of JS bundle and everything. Full control of the native camera. Check. We could use multi-camera devices. We could switch the camera. We could have, while recording, we could still, while getting a call, we could still record and everything. But filters, did we solve filters? We didn't solve filters, no. So how do we do that? We have 2 requirements for filters. We want to detect things in a frame, and we want to draw onto a frame. So what do we want to detect in a frame? We might want to detect faces of humans, faces of dogs maybe objects, maybe QR codes, maybe even custom circular codes. If you're familiar with snap codes, maybe we want to detect if an object is a hot dog, and many more things, right? We want it to be very flexible. Obviously, we can't just build, all of those things into VisionCamera and, enable human face detector, enable hot dog detector and everything. So we want it to be, very flexible, and that's where a plug-in approach comes in. So what do we want to draw? We might want to draw color filters. We might want to draw beauty filters. might need those. We might want to, draw the QR code outlines on a QR code. We might want to, do some animations there, some real-time face blurring maybe, all kinds of different things that we want to do in real time, and want to also write back to the recording, obviously. So we can just draw it on the screen. So remembering the 6 API design principles, I guess, I used for VisionCamera, want it to be user-friendly, self-documenting, lean core, no platform specifics, and no compromises in flexibility or performance. How do we achieve that? I noticed that, or I took another look at the native platform APIs, and I noticed that there were they have two things in common. There was one callback method, or the native callback method, for a new frame on both platforms. So on iOS we have capture output, and then we have the sample buffer here, which is the actual image buffer that's allocated on the GPU. On Android, same thing. We have image analysis, and we get an image, and we can close that image, and we can do any kind of stuff in here. So how do we keep that flexible? We know we have those APIs on the native side, but how do we keep it flexible for the React Native API? We run the callback in JavaScript. So that was the whole idea. We want to run it in JavaScript because that's how React Native works, right? All of your business logic is in JavaScript. You can do some, lots of stuff in JavaScript. The benefits were pretty obvious. Same benefits as with, React Native in general. It is extensible with any user code. You can hot reload for quick development changes. You can update over the air. If your app is in the App Store and you want to ship some quick config change or anything, you can use code push, for example. And you can just do anything you want in JavaScript, right? Console log, state, some configuration, and pass all of it to native, where the actual performance is. So yeah, how do we keep it fast? I mean, we all know that, the callback is executing in real time, right? So if I'm running at a 240 FPS format, that's going to be, lots of calls over the bridge. So right now, or at least before the turbo modules or before JSI, there was this bridge, and we know that the bridge is asynchronous. The slow part here isn't actually, true per se. I mean, the bridge is pretty fast, but it is asynchronous and it is batched. So that won't work for us. We need it to be synchronous and really fast. JS is too slow for ML algorithms, so we can kind of conclude here already that we need to run the actual algorithms. So ML algorithms, for example, a QR code detector is an ML algorithm, or like a face detector. We want to run those in native code, or like, with TensorFlow or something, like a pre-trained model, right? That's where the speed is at. How do we pass a frame object from native to JavaScript? That's another problem. We can't just create a byte array and pass it over the bridge. That's going to be very, very slow. So how does it work in a native app? Again, let's take a look at the native side first and then see what we can do. So in a native app, you'd use APIs like TensorFlow, Apple Vision, PyTorch, maybe MLKit to kind of load your model, which it might be a QR code detector, a face detector, or any kind of custom model maybe. And then execute it, right? So you can execute it with a new frame, you can read the results back, and those algorithms usually run on the GPU. There's some devices that have an NPU, so some newer Apple devices have an NPU as well. That's even faster than a GPU. I think only Apple Vision runs on NPU, maybe TensorFlow as well. I think there's some plugins for that. And yeah, so inside the native callbacks that we saw earlier, you call those APIs and then get results back. Right. So the abstract idea was that we call this whole thing frame processors. I think the name is fairly obvious. It's one JavaScript function that gets called, for every new frame that the camera actually sees. So you receive the frame. You can run any JavaScript code in there. You might, want to read some state from the React tree. You might want to, have some other config, some logging maybe. And then you call into native plugins that actually do like the heavy lifting, right? The actual algorithms that run on the GPU, that has to be native code. So the technical challenges here, again, it is asynchronous, and when we call, or when we run a callback call a JavaScript function from native using the bridge, that's like the legacy approach, the frame might already be gone, because by the time that the actual JavaScript function executes, this is on another thread, this is batched and everything, so the frame might actually be gone already and the new frame is there. So yeah, the frame object can't just be passed as a byte array. because the frame object is like a full image buffer that's allocated on the GPU. That's like, at 4K, that's around 10 megabytes. And if you, sum that up at 60 FPS, you're at 600 megabytes per second. And then after just 1.5 seconds, you're at 1 gigabyte of data being passed around. So you can't really, use byte arrays or number arrays or anything for that. Especially not because JavaScript is a garbage collected language, and then it doesn't delete the object immediately, but rather until it hits memory limits, and garbage collection is slow. So yeah, the React Bridge also only supports primitive types. You can pass strings, numbers, JSON around, but not like complex objects like GPU buffers. So what's the solution? Synchronous calls. There was a time when JSI kinda started being a thing. We want to call the JavaScript function synchronously in a native frame callback and kind of wait for results, or wait until it, I guess, returns, wait until it's complete. And all of this was powered by JSI. So at that time, I think Reanimated 2 was the first library to use JSI, like, in production. And yeah, that seemed to work fine, right? So what is JSI? JSI is the JavaScript interface. It provides a binding layer between C++ and JavaScript, so your JavaScript runtime is built with C++, and you can call C++ functions from JavaScript, and vice versa, right, the other way around. Perfect, that sounds like exactly what we need. So we want to pass the frame object to the JavaScript function using JSI. And there's actually a convenient thing here called the JSI host object, which you can just use to wrap the native GPU buffer of the frame as a C++ class, and then anything that can be exposed to JavaScript, like let's say frame.width, we can access the width of the frame, is actually backed by a C++ implementation. Yes, so C++ host objects, JSI host objects. Can you read that? Yeah, I think you can somewhat read that. This is like a very minimalistic, I guess, stripped down version of the frame host object that I have in VisionCamera today. So as you can see here, there's the frame, the actual native frame object, and then the host object itself has some methods exposed that can be used or that get called when you access it in JavaScript. So right, it has getters, setters, and functions. For the frame object, we don't need setters. We need getters and functions though. And this is, for example, let's take a look at an example here. If we access frame.width in JavaScript, not sure if you can read that, the C++ getter method is called, or the get function, with the, JavaScript is dynamically typed, so the name contains a string called width. And on the C++ side, this is the code that actually executes. I get the native frame width, so here I use cvpixelBuffer get width, which is, I think it's an int, maybe a long, something like that. Then I just wrap it in a JSI value, which is, a JSI value is the one type that can be used in JavaScript. And yeah, in this case, it's a number. And I then just return it here, which then returns it to JavaScript. And in JavaScript, I can access the value, the frame width, as a normal JavaScript number. And just console.log it or whatever. Same thing for functions. There's a toString function, and as of VisionCamera v3, there's also a toByte array function, so you can actually access the byte array. I'm not sure what you want to do with it, but I just expose it here. Yeah, okay, threading. That's another difficult thing. JavaScript is single-threaded. There's no concept of multi-threading in JavaScript, so no logs, no way to I guess do multi-threading here. And the camera streams frames on a camera thread. So we want to call it synchronously, but JavaScript does not run on a camera thread. JavaScript runs on a main React thread. So yeah, to keep it synchronous, it needs to run on the same thread. How do we do that? Worklets. So yeah, this was the time when Reanimated 2 came out. So this was quite convenient for VisionCamera because I wanted to use the same concept in VisionCamera. Worklets are small JavaScript functions that are extracted out of the main React.js runtime. Then you create a second JavaScript runtime on another thread, and you can then just inject the worklet there and call it on that runtime, while the other runtime is doing something else. So it extracts context and I guess all of the captures, all of the values that you use, and then you can use it on another runtime. So that's exactly what I want to do. So yeah, Software Mention brought worklets to React Native. And in Reanimated 2, worklets are used for running stuff on the UI thread. So they're already doing it. It works. It's being used in production. And they use it for use animated style or use derived value. And yeah, I just thought, why shouldn't I just use it for VisionCamera as well? So yeah, I tried integrating Reanimated and VisionCamera to use worklets. It required some changes in the Reanimated repo, so there were lots of discussions with the software mention team. So thanks again for all the help there. But yeah, we made it work so that you can actually create. So with Reanimated 2, it was only focusing on the UI runtime. But then with a few PRs later, you can also use a second or a third or whatever more runtimes. Basically, it was not tied to just the UI runtime. Yeah, so the frame processor itself is the JavaScript function then that's converted to a worklet and then brought to the camera thread JavaScript runtime. So create a separate runtime there. And I mentioned the plugins before, so that's where you actually want to run the native code. Yeah, so you want to extend frame processors. So that's the one terminology here, frame processors. Those are the JavaScript functions. Can be extended using frame processor plugins. Those are actually the native, the native implementation that you can call in your JavaScript frame processor. They receive a frame and some other parameters and return any kind of value that you can use in JavaScript. So they're kind of like native modules. So VisionCamera has its own implementation of native modules, if you want to call it that. Actually, not turbo modules, but like synchronous native modules. And the frame processor plugin is very simple. I want the user to be, not overwhelmed by all of the camera features. So I think it's just a few lines of code, and then you can just do whatever you want. In the callback, let's take a look at how that looks. Here I have a detect objects frame processor plugin, which just extends frame processor plugin. That's the base class. Then you have to override the name function. Here I call it detect objects. That's the name of the function. And then you just override the callback function. So you get the frame here, and you get any arguments here. Might also be no arguments at all, and you can return anything. So for the detect objects frame processor plugin, I use MLKit as an object detector. I pass the image to the object detector, and then just see, or I guess convert all of the objects to simple JavaScript dictionary, I would say. So that's very simple. That's actually the working code. That's not like pseudocode or anything. That's how it looks. And then that's how it looks like. So you can use the frame processor in JavaScript. As you can see here, I use reanimated concepts as well. So I have a shared value here. I assign, or I call the native plugin here. So frame processor plugins.detect objects. That's the name we used before. Pass the frame along, and then I get the objects back. And I just use the first label, and then I render it to the screen using Reanimated 2 with a normal reanimated text component. Right, and that seems to work very well. So let's take a look at performance. JSI is really fast. It's synchronous. We don't have any batching going on. It's not converting anything to JSON. It's just passing it along, calling it synchronously, and that's it. It is, however, still an abstraction or a higher level API over like the actual C++ bindings that you have in a runtime. So for JavaScript core or for V8 or for Hermes, there's bindings to from C++ to JavaScript, and they all get, I guess, unified in this JSI API. So it's kind of an even higher level API. But the frame does not have to be copied, so the 10 megabytes are allocated on a GPU. The system maintains it. I pass the reference to JavaScript. You can do anything you want with it. But once the frame processor finishes executing, the frame is gone. And simple frame processors can run up to 1,000 FPS. I don't know what camera supports 1,000 FPS, but you can do it. Yeah, benchmarks. I built the same app in Objective-C and in React Native. I used MLKit Vision image labeling to label 4K camera frames in real time. So that's the example you saw before with the car and everything. In a native Objective-C app, we had 68 milliseconds per call. And in a React Native app using VisionCamera, we had 69 milliseconds per call. So it's a 1 millisecond delay. I would call that as fast as native. If anyone wants to disagree with me, meet me outside for a fist fight. So what's all of this for? Here's some examples we built. So Thomas is not here, but he built this for a client of Margelo, where you can just scan the card, and it detects all of the text on the card. yeah, simple stuff. Then we have a pretty cool app that's called Unbogify, I think. And you can actually, it's running at 240 FPS, the recording. The frame processor itself is running a bit slower. I think it's throttled down at 60 or 50 FPS. And it detects your pose, actually, and tells you, or detects a golf swing. And it tells you how good that golf swing actually was. So quite a cool app. It's built using React Native VisionCamera. It is on Product Hunt if you want to check it out. Then we have the custom QR codes that I mentioned before. Here's some circular codes that we built. It detects the outlines, all the points, and the text, or it can, I guess, decrypt the text in it, if you want to say. So that's just like a QR code. Yeah, so what's the future of VisionCamera? Lots of apps are using it today. What's the future? I'm currently working on VisionCamera v3, because I'm not sure if anyone noticed, but I didn't mention the draw onto a frame stuff yet. I only mentioned the, detect things in a frame. So in VisionCamera v3, we want to, or at least I want to give the users the ability to draw onto the frame using React Native Skia. So if you've used React Native Skia before, it's quite a cool API. It's a cross-platform 2D rendering API, so you can draw anything you want. For example, you can do color filters. That's the part we talked about before, color filters and beauty filters. Using Skia shaders, so that's the SKSL language. We can draw face outlines, like draw rect. We don't have to use SVG or any views anymore. We can just draw it using Skia onto the frame directly, which is being recorded and saved to a photo file as well. So there's the benefit here. Plus, Skia shaders can actually, use the image as a uniform. I'm not sure if anyone here is familiar with shader language, but then you can actually run, stuff depending on actual pixel values instead of just drawing something on a frame, or at least on, as a view on top. React Native worklets, we've got to talk about that. So yeah, I had some issues with Reanimated before where some build errors or some build things failed. So yeah, I wanted to find a solution to that to kind of make it more stable, because that's the core, the root of most build issues so far. And I want to find a good solution to that, because I don't want, if I depend on Reanimated, I want to only depend on the worklet part of Reanimated instead of like the whole, layout animation and everything. So yeah, that's something that I'm thinking about. Plus ML models from JavaScript. This is quite interesting actually. Because with React Native Worklets or Reanimated 3, you can actually use host objects from outside of the worklet, meaning that you could theoretically create a TensorFlow wrapper around TensorFlow, the native APIs. You could load your model using, you could just drop your model in the source/assets folder, so on the JavaScript side, then load the model here, and then just call the method in the frame processor, and then you don't have any native code at all. So you just drop the model in, use the one API that, those bindings should be very simple. And then, yeah, that would be pretty cool as well. So VisionCamera v3 works. Here's an example where I draw to the frame itself using Skia. I just censor my face out. So yeah, it detects faces here, and then it uses Skia API to create a rectangle using the color red, and then draws it onto the frame. So frame.drawRect. And yeah, that seems to work fine. So that's also running at, I think, up to 200 FPS, so the Skia thing. Obviously, the detect faces thing depends on what API you use. I think Blaze or Snapchat uses Blaze face. That's a pretty fast algorithm. But yeah, that's also pretty fast. Here's another example with color filters. So this is an invert color filter, and this is a VHS filter, where it uses the image as a uniform shader and draws it back to the screen. Yeah, here's another example. That's actually not running very smooth at all, because that was the first actual working prototype of V3. And yeah, any questions? Yes.
Recurrently, how hard is to, when in this case, look up and reframe ML models in the traditional camera? Because also when internally, I'm not sure if it was already discussed, but yeah, when I think maybe yes, but it would be great to, for example, to have a reframe model to scan receipts and yeah, to fill the information.
Yeah, that's a good point. So I think this is kind of similar to this thing right here. We can actually scan a receipt, maybe train it to scan or to detect receipts, and then just scan the text on a receipt. So that's probably going to be something maybe interesting for Expensify. Yeah, so you would currently in V2 and V3 you would implement this using a native plugin. So you write a native frame processor plugin, which is just Swift and Kotlin code. So compared to a native module API, you don't need Objective-C. And you use, I don't know, maybe MLKit, maybe TensorFlow, maybe PyTorch, whatever you want. It's just like in a native app. So you just use any of those ML loader models that you want, pre-train the model. I'm pretty sure there's receipt scanning models out there. If not, it's probably not too hard to build one yourself. And then just run it there. And then that gets exposed to JavaScript, to the frame processor, and you can use it there. I don't know how much effort that is. It's fairly straightforward. Yeah. Any other questions? Andrew?
With VisionCamera 3, are you still sticking with Camera X, or are you switching to Camera 2?
Interesting question. So, I need to repeat the question, right? So the question was if I need to, or if I want to stick with Camera X on VisionCamera V3. Currently, yes and no. I mean, I have a prototype running on Camera 2. Again, Camera 2 requires lots of, I guess, device-specific workarounds, which Camera X fills in, right? It's kind of like polyfills. So yeah, there's some Huawei devices where something doesn't work, and it's much more difficult to use. Again, I have a blog post on that. But yeah, so I don't really have an answer to the question. You can use Camera 2 from C++, so the Camera 2 NDK, which would be cool because cameras, or like the Android platform, you write Java code, but the camera itself is a hardware sensor, so it's coming from C++, going to Java through the JNI, then going to C++ again, and then to JavaScript to expose it to React Native. So it would be cool if we're like, C++, JavaScript, that's it. But this obviously comes with a lot of added complexity. So I'm kind of researching it right now. It's a lot of effort. I'm guessing it's like a 300-hour rewrite or something like that. And yeah, I don't, really have the time for that right now. So V3 is almost done actually. So I'm hoping to release it in a few weeks with the full, Skia drawing support and everything. I still need to do the Skia part on Android. I mean, most of it is cross-platform, but I still need to create the preview layer. And then I will release V3 with Camera X probably first, and then maybe do Camera 2 as a, 3.5 or V4 maybe, something like that, if I actually, want to do that. Because again, you have, there's lots of drawbacks with that. Yes, you were first, yeah?
Did you, at any point while researching this, cameras in general, consider web APIs or a cross-platform version of the camera, or does it just not align with
Do you mean like if there's any C++ API or something like that available to wrap all the native platforms, or what do you mean?
On web.
On web? Oh, okay. So the question was if I ever considered tapping into the web camera APIs. I took a look at web camera actually, and there's, most of the concepts are kind of similar to the native platform. So you still have, I think, devices. I'm not sure if you have formats, but you have devices, you have your session, and you have the view. So, straightforward stuff. But I didn't do any, no big research on it yet. It's another platform you have to support. Lots of, I'm the only maintainer of. I mean, there's some help from T-Bolt, for example, but yeah, I really, it's all the native code is all kind of maintained by me, so I would have another platform added there. Yes.
So earlier you mentioned about different capture devices, and I was wondering if you're also integrating microphone and or Face ID also into this or not?
Oh, that's a good question. So the question was if or I guess what kind of capture devices you can actually use in VisionCamera V3, and if the microphones and TrueDepth camera is supported. Yes, you can. So I currently comment out the TrueDepth camera because you can't really use it for preview. You could use it for frame processing. So you could get, depth data frames. They're not a YUV or RGB format, so they're depth data format. But you could use those for frame processing, and I think that's just a one-line change, but you don't see anything in a preview. So actually, that's a good point. I should look into that later. Microphones, you cannot process microphone data right now, but you can, enable audio and disable audio for video recording, but you cannot do audio frame processing. But fun fact, the Unbogify app actually built a custom, so they have a VisionCamera fork where they have audio frame processors for detecting, when the what is it called? The thing hits the ball. Yeah. So they detect that using an audio frame processor as well. And then there's also the LiDAR sensor on newer phones, which would also be the same thing as a true depth sensor. Yeah. Any other? Andrew again.
Were there any lessons learned or anything you can share from maintaining like such a popular library like GitHub?
So the question was, were there any lessons I could share from, I learned from maintaining such a popular library? Yeah, so I have a very radical approach for maintaining VisionCamera and making sure that it gets actually maintained. So I just don't really care about any issues. So I just ignore all of the issues. I have everything muted, and I just use it in, I think, 3 or 4 production apps, and it works for me, right? So, I improve it, I work on interesting features, and if something breaks for me, I fix it. But I don't really care if anything else breaks. And if someone wants to pay me to fix it, I'll do it, right? But if someone just dumps their, stack trace or anything there, I don't really take a look at that, to be honest. Anything else I learned? Well, yeah, creating API documentation is important. So kind of like a good README, point the people to where they actually need to take a look at. I also point people to Camera X issues, so they can maybe see if it's like a native API limitation. And yeah, I think that's all the lessons I learned from doing that. Yeah. Any other questions? I should probably look at the chat, right?
Only funny memes.
Funny memes? What's the meme? The not hot dog app. Yeah, that's okay. Any other questions right now?
How many issues are in the report?
I don't know. I think there are probably like 300 or so open issues, but I don't really close all issues, right? Sometimes I go around closing like stale issues if I still, remember, okay, this is fixed already or something like that. And most issues don't really make sense, right? There's issues like, hi, how can I use it to detect faces? I'm like, that's not really an issue, so I just close it immediately. Yeah, I should probably add some maybe a moderation bot or something there. It's something that would be smart, yeah. I took a look at PRs though. So every PR gets thoroughly inspected by me. Yeah. Yes?
What are some high-profile apps that
So there was Locket. I'm not sure if you know Locket. That's like an app where you have a widget on your home screen of your significant other, and you take a picture, and then the other person sees it. I still have to talk to this one guy I met who works at Tesla, because I think they tried using it in a Tesla app. I'm not sure if they're using it right now. Anyone else? I don't know. I don't really know. If a big app uses it, they're not going to tell me. So that's also another lesson for open source maintenance. You only see issues. You don't see people like, oh, this works great, thanks. You don't see that. So if there's 100 issues, I'm just hoping that there's like 1,000 people using it successfully, right? But yeah. Yes?
You have to work with
With Android? Sorry?
You have to work with Android X developer.
What do you mean with Android X developer?
Because of maybe issue with Camera X.
Oh, you mean if I worked with a developer from the framework, from Camera X or from Android? Yeah. I did, fill out issue reports and stuff like that on their issue tracker. And I talked to this one guy from Google who shared the funny meme with me. But yeah, there's really, they're maintaining it. They're doing their own thing. They appreciate it if you, post some thorough like crash reports or something like that, because that's most important to them. But, they don't really share any feature roadmaps or anything for Camera X. So yeah, I talked to them through the issue tracker. Yeah. Any other questions? Looks like that's it. Okay, if you have any other questions, just, find me. This is how I look like. Or just ask in the ExpensiConX chat. And yeah, thanks everyone for listening. Also thanks ExpensiConX for having us here. I really appreciate it. Yeah, thanks.
Yeah. All right. Thanks, Marc.